All right, here are the things that you'll need today. You'll need your iPad, a pencil, your green math journal, and your math notebook. Make sure you are taking notes during this time. It's really important. So our title for today is Congruent versus Similar, and add that to your notebook. And then our learning target, today you'll work to have a better understanding of how to calculate and know the difference between similar and congruent. Very cool. So I've highlighted a couple things here. That's pretty much all you're going to need to write down, the things that I've highlighted. But congruent means exactly the same. So these two triangles are congruent because when I lay one over top of the other, they are exactly the same. They have the same shape, size, and they are then congruent. Now, similar, you can see right away from the look of these are not the same size, so they're not congruent. But if I take and drag this guy over, there he comes, I can see that yeah, he is, that angle is the same, and that angle is the same, and then down here in the corner, that angle is the same. So they're similar, and these similar figures have the same shape but not the same size. So make sure you write both of those definitions, congruent and similar, into your notebook, and then let's keep rolling. Now this is a term we won't talk a lot about today, but I wanted to just cover it. The term is adjacent, and adjacent angles are two angles that have a common side and a common vertex. So vertex is here at B, common side would be C. Now they can't overlap, and do not confuse this with supplementary or complementary. Complementary angles are working off that 90 degree, and supplement are working off 180. These are just next to each other, adjacent. So if we said the house adjacent to yours, that's the house right next door, okay, on either side of your property. All right, let's keep rolling. Make sure you add that to your notebook. Pause the video and kind of think about which ones are similar and how can you tell. All right, now the triangles are similar, and find the value of x. So this one's a little goofy. Why don't you try and get these shapes drawn and labeled into your notebook, and then we'll talk about this on the next slide. All right, so here you have the values for x. X is 2, x is 16 on this side. But how do we really know that? We can look at 5 is half of 10, so this x maybe needs to be half of that value. But then when we come over here, yeah, 12, 9, 9, but it's 16. Yeah, it's goofy. So let's think about, how do I do this? So if you were thinking ratios and proportions, you were absolutely right. So what I did here was I took the two sides that are possibly the same, the 5 and the 10, and I set those as the numerators. And then I set here the 4 and the x as denominators. Now I'm going to cross multiply. 10 times x is 10x, 4 times 5 is 20. And then I'm going to divide both sides by 10, x is equal to 2. So there, now I've kind of got some math to back me up and prove that. But if I jump over here, I'm not really even certain what I'm looking at. So I did some cool work with this one. And aha, yes, I can see that that's what I'm comparing. So I'm comparing that 9, that's a 9. It looks like a 6, I know, but it's a 9. And that's a 12. So I'm comparing those bases, and then I'm comparing 12 to x. So I'll spin that back around so you can see that that's a 9. All right, I'll put that guy back. Whop. All right, now, so I've set that up. X is being compared to 12, and 12 to 9. Again, let's cross multiply. 9 times x is 9x, and 12 times 12 is 144. Divide both sides by 9. Voila, x is 16. So you can use those ratios to find out if they are similar. Super cool. We're going to have some fun with that tomorrow. So here, and this is exactly what we're going to be doing tomorrow. No, I'm not sending you off to measure the Great Pyramids of Giza, but Thales was a Greek philosopher and a mathematician who lived around 600 BC, and there are several accounts of how he used indirect measurement to find the height of the Great Pyramid of Giza. So according to one account, when his shadow was the same length as the height, he measured the length of the pyramid shadow and Well, what does this have to do with similar triangles? Just what I just showed you. You're using those ratios and proportions. So think about that, and we'll be experimenting with that tomorrow. I'll be sending you outdoors for math to do some measuring. All right. So here, tell whether the triangles are similar and explain. So what I want you to do is I want you to pause the video. I want you to work through these on your own and see what you can find out. And I will see you on the next slide. All right. So this first one, letter A, this one is really easy to say that, hey, these are congruent because we already have two angles that are the same. And since we're working, if we have two angles that are exactly the same, and they're both triangles, so we're working on that 180 degrees, we know that X and Y are also exactly the same. So the triangles have two pairs of congruent angles, so then that means that the third angles are congruent, and so therefore the triangles are similar. Now, let's take a look at B. So B, we're going to write out an equation. X plus 54 plus 63 is equal to 180. I bet it was a little hard to see some of those numbers. Apologize for that. When I add 54 and 63, I get 117. 180 minus 173 leaves me with X equals 63. Now, the triangles have two pairs of congruent angles. So the third angles, therefore, are also congruent, and the triangles are similar. Now, we can see that this one is probably smaller than that one, so we can say that they are similar. All right. And this last one, letter C. So we wrote an equation to solve to find for X. X plus 90, that's that 90 degrees right there in that corner, plus 42, and that is equal to 180. 132 is equal to 180. Subtract 132 from each side. Okay, so we subtract the 132 from each side, and we get X equaling 48. And we do not have two congruent angles, and so we don't have a third congruent. So we would say that these are not similar. They're just a little slightly different, but that's where we have to be really careful with this. All right, same thing here. I want you to go ahead and add these three to your notebook, and then I want you to go ahead and solve for them, and I will see you on the next slide with some explanations. All right, so let's take a look at A. So A here, the triangles are not similar because the triangles do not have two pairs of congruent sides. When we take a look at this first one and we add 43 and 58, we get 101, and we have X equaling 79. So we have a 43 and a 43, but a 58, no, we don't have the same angles. So we can't say that they are similar. All right, now this next one, letter B, we take the X plus 52 plus 48 equal 180. X is 100. X plus 100 is equal to 180. X is equal to 80. The triangles do have two pairs of congruent angles, so the third angles are congruent, and the triangles are, that's right, the triangles are similar. Make sure you're adding this to your notebook. All right, and letter C. X plus 90 plus 43, so that 90 degrees comes from that little red box, which tells us this is a right triangle. We see that this is also a right triangle, so really, if X equals 47, which it does, when we do our work, the triangles have two pairs of congruent angles, so the third angles are congruent, and the triangles are, that's right, triangles are similar. All right, I hope this is making sense. Again, I want you to do number 1 and 2, and when you have both of those done, I want you to come on over with me to the next slide. So pause the video, do your work, and I'll see you on the next slide. All right, so tell whether the triangles are similar. No, the triangles do not have the same angle measurements. So these yellow ones in the first example, they are not similar. Now these two are similar because they have the same angle measurements. So we see they both have that 90 degree, and they both have that, well, this one has a 66 degree and a 24. So they have the same angle measurements, so they are the same. And really that number 2 is exactly what I showed you when we were talking about similar earlier on, where I drug my little triangle to the 3 corners. They all measured out the same. All right, let's keep rolling. All right, now this one, this problem will show up, or a very similar one will show up on a test. Okay, so you plan to cross a river and you want to know how far it is to the other side. You take a measurement on your side of the river and you make a drawing shown. Explain why triangle A, B, and C and D, E, and C are similar. And then what is the distance across the river? So the distance across the river is over here at X. Okay. And so really we have to do the exact same thing that we've done before. I want you to try this one using proportions and ratios and see what you get. I'll see you on the next slide. Okay, so angle B and E are right angles, so they are congruent, and angles ABC and DCE are vertical angles. Remember vertical, where they're just diagonal from each other. Those are the same. Those are congruent. And because 2 angles in a triangle are congruent, that means that the third angles are also congruent and the triangles are similar. So if the triangles are similar, now we can use ratios of the corresponding side lengths. So corresponding just means that we're comparing each to each. So X is going to be what I would normally call A. So we're going to compare X over 60 and 40 over 50. We're going to cross multiply, okay, and we're going to be left with X equaling 48, okay. And so the distance across the river is 48 feet. So the length of that right there is 48 feet. That is really cool. I would make sure you have that in your notes. I would study that. I would know how to set up the proportions, and that you're going to see something very similar to that on a test. All right, trying to help you out there. All right, this example 2 is for you to do. I hope you can see all of the dimensions there, 50 and 40, 30 and X. Same as what we just did. I'll go over answers over here on the next slide. Pause the video. All right, so I'm just going to leave you with those are the answers. This is the exact same work we just did. Okay. All right, I'm going to keep rolling. All right, now this is our last bit today. So mini assessment, if you can do these 4 problems without any problem, you're going to do great in your homework. Well, it's all homework, but in your big ideas work. So go ahead and do these 4. Pause the video. All right, so here are the answers, and let's just kind of go through those quickly. This one is definitely, yes, the triangles have the same angle measurements, so they are similar, okay? And no, these 2 triangles, they have some similarities, but they do not have all the same or enough angle measurements that are the same. And then number 3, yes, these triangles have the same angle measurements, 82, 62 degrees, and 36 degrees. All right, and then the last one. A person that is 5 feet tall casts a 3-foot shadow. A nearby telephone pole casts a 12-foot long shadow. What is the height in H of the telephone pole? So that would be 20 feet. That's exactly what we're going to be doing tomorrow for our math lesson. So make sure you understand that one. And that's really just setting up those ratios, and you're setting them up so you have same over same on both sides, cross multiply, and then solve with the algebra. So that we can tell the height of that telephone pole by that. All right, here is one more for you. This is the last one, I promise. Pause the video, do this one. All right, and the triangles have the same angle measures, 94, 48, and 38. So the triangles are similar. All right, I hope you feel good about this. I certainly do. And I hope that this is something you understand. You know how to get a hold of me, Google Voice or Google Hangout, if you need help with this. All right. Really make sure you understand this because you're going to use it tomorrow. And I think we're going to do another flip grid. All right. Have a great weekend. See you on Monday.